Okay, a very warm welcome to everybody here today. We've got people from all over the world. We've got people from Canada joining us, and the title of our discussion is Decarbonisation and Renewables, New Environmental Impacts to Mitigate. And the whole problem, why we chose to do this panel discussion is that we recognise that decarbonisation is necessary, and it is necessary to move away from coal mining towards mitigating climate change. But in doing this, we recognise that there are going to be substantial biophysical and socio-economic impacts that will need to get mitigated when existing coal mines close and with the opening of new mines to service the renewable energy production that will be required. So our panel is wanting to unpack all of these complex issues around the transition. So we'd be starting with contextualizing the just transition, then delving into the type of minerals and quantities that will be required, then looking at the likely impacts associated with closing and opening mines, and then looking at renewable energy production and recognizing that this is not without substantial impacts. And then lastly, we'll end off on a positive note to provide a vision of what mining could look like into the future. So it's going to be chaired by myself, a network accredited specialist with Enterprises University of Pretoria, and I also do independent environmental research work. And then the co-chair is Jessica Broadhurst from Jones & Wagner, and she's an environmental scientist. And Jess, I'm going to hand over to you to introduce the panelists.
Great, thanks so much, Vanessa. So we would firstly like to introduce Gaylor Montmasson-Clair, who is a senior economist at Trade and Industrial Policy Strategies, also known as TIPS. He has been working on green economy issues for more than 12 years and has carried out extensive research on the transition to an inclusive green economy from a developing country perspective. Then we have Associate Professor Jennifer Broadhurst from Minerals to Metals at the University of Cape Town. Jennifer has more than 35 years research and development experience in the field of minerals beneficiation within various industry and academic organizations. Another one of our remarkable panelists is Jessica Edwards, who is a senior social consultant with over 18 years experience in social safeguard practices. She has been at the forefront of developing mechanisms to ensure social transition towards mine closure, to ensure a sustainable transition for communities beyond mining. Also joining us all the way from Canada is Mike O'Kane, who founded O'Kane Consultants, a company providing integrated mine planning and closure outcomes to the mining industry internationally. Mike fulfills many different roles on various levels and provides independent peer reviews to mine operators and owners, as well as state, territorial, provincial, and federal government agencies, and is a member of several closure planning and technical advisory panels. Lastly, we have Taryn Bigwood, who is passionate about aspects of the environment and has worked in multiple sectors from conservation to development, water, energy, and mining in an environmental capacity. Among many of her other achievements, she is currently in her third year as an advisor on the United Nations Committee for Combating Desertification in South Africa. Thank you to all our panelists for taking the time today to share your expertise and to lead the discussion on decarbonisation and renewables. I'll then hand back to you, Vanessa.
Thanks, Jessica. So I think if we can start with Gaylor, who will cover the just transition and contextualise that for us. So I'll stop sharing and Gaylor can share his slides.
Thanks so much, Jessica and Vanessa for the introduction, and thank you for the invitation to be part of this panel. Good day everyone. And as you rightly introduced, we are in the midst of a transition triggered by climate change, by environmental sustainability, as well as a technological transition that is highly disruptive. And it's important to understand that people, but also communities, companies, and countries have a different ability to respond. And that triggers really the need for just transition. It triggers the need to make sure that vulnerable stakeholders, and we intend generally vulnerable stakeholders as workers, small businesses, but also low-income communities, are actually not negatively impacted by the transition, or even ideally are better off through it. You don't want vulnerable stakeholders to once more bear the brunt of a transition process. When we think about a just transition, we think of three key aspects. The first one is what we call procedural justice. It's premised on the fact that you can only have a just outcome if you have a just process. The second one is what we call distributive justice. It's about dealing with the loss of livelihood, the loss of employment, the so-called sort of direct impact. Some people are going to be negatively impacted. We need to take care of it. And then we have restorative justice, which is really where ambition lies. And it's trying to deal with all the legacy impact. In some sorts, we're trying to kind of right the historical wrongs, if you want, through that process. So, of course, that's a hugely ambitious agenda that is being carried out through just transition narrative. If we look as an application to the coal value chain in South Africa, which, as you pointed out, is going to be negatively impacted, we need to think about workers. And in South Africa, we've got about 150,000 people who are directly employed in the coal value chain. Okay. Importantly, those people tend to fare better than others, than the rest in the economy. And that's quite important because when we think about alternative livelihood for those people, we need to take that into consideration. Those 150,000 workers, of course, they support a much bigger community, through indirect jobs, but also their household and community overall. You'll find that most of them are in mining, but also transport, and that's around coal production and transport. These jobs are directly at stake. If we don't mine coal anymore, those jobs are really at risk. Then you've got jobs in the use of coal, largely in power generation, but also in petrochemicals, in steel and cement. Those will definitely be transformed. We could keep them if we manage to find alternative feedstock, maybe, for those employments. And of course, look, a variety of other industrial activities are being supported through the coal value chain in South Africa, and it's important to understand. So that's really the direct job picture that we need to keep in mind. On top of that, we also need to understand that we're looking both at permanent and contractors. For instance, if you look at the extent of coal mining in South Africa in the graph over the last 2 decades, the rise is largely in contractors. So it's temporary jobs, and so we mustn't only look at permanent employment. Beyond workers, we need to look at communities. If you look at coal mining in South Africa, it's essentially in Mpumalanga, in the Highveld, and you find that actually 4 municipalities are really at risk, really highly undiversified and relying on coal mining. That's eMalahleni, Steve Tshwete, Msukalingwa, and Govan and Mbeki, where virtually nothing moves if not for coal mining and power generation. That is neatly illustrated if you look at the economic activity in those municipalities. You can see the block here around coal mining itself, about 40% in eMalahleni, and everything else is directly or indirectly related to that. So we really need to understand that it's a community-wide impact. What to do about it? Of course, as I mentioned, we have 3 dimensions. The process needs to be bottom-up. The restorative justice is fundamental. But in the short term, it's also about, and primarily about, the direct impact. And here we need to think about the diversification of the economy. And here, really, my plea is that we take a broad view. We don't limit ourselves to say, oh, we need to replace coal jobs with renewable energy jobs or even energy jobs. Of course, some people will move from renewable energy, from coal to renewable energy or energy. But let's look at all the opportunities. Agriculture, forestry, tourism, turning our liabilities into assets, manufacturing, services, and so on. And that is the extent of the challenge, but it is also the extent of the opportunity. And I hope that sparked some good thought for you and set some good background for the rest of the debate. Thank you so much. Look forward to the discussion.
Yeah, so the next person I'm going to call forward is Jennifer, to talk about the large quantities of minerals, where they're going to come from, when you're moving away from coal, and, the type and the quantities. So Jennifer, if you could carry on, I will share your slides for you.
There we go. So you can go straight on to the next one, I think.
Yes, there we go. Yes,
Right,
on to the next one. Off you go.
Yes, off I go. So I think it is common knowledge that as our technologies have become more advanced, so we have used more and more different types and greater quantities of minerals and metals. And this is particularly the case over the last century. And following these trends in terms of the resource intensity of advanced technologies, the low carbon or clean energy transport and power generation technologies tend to use significantly more minerals and metals than traditional fossil fuel-based technologies. So according to a recent report by the International Energy Agency, a typical electric car requires 6 times the mineral inputs of a conventional car, and this excludes the chassis. And an onshore wind plant requires 9 times more resources than a gas-fired plant. Next slide, please. So in terms of the types and relative quantities of minerals and metals, renewable energies such as solar PV and wind turbines use significant quantities of aluminium, iron, and copper, as well as lead, molybdenum, silver, chromium, nickel, zinc, indium, and also the rare earth mineral neodymium. Metals such as aluminium, copper, chromium, iron, and zinc also feature in battery storage, although the predominant minerals are graphite, nickel, manganese, cobalt, lithium, lead, and to a lesser extent, vanadium. Next slide, please. So in accordance with the latest World Bank predictions, keeping global warming below 2 degrees is going to require relatively large increases in the supply of these metals and minerals by the year 2050. So this pertains in particular, and as we can see from this graph, to the battery minerals, graphite, lithium, and cobalt, which an increase in demand of nearly 500% is estimated. And even though the increase in demand for some base and bulk minerals, your aluminium, your copper, your iron, appears to be much smaller in percentage terms, their absolute predicted demand production figures tend to be very much higher. The next slide, please. And this is reflected in this graph, which shows that iron and aluminium will have highest absolute increase in demand by 2050. So we're looking at 200 and 100 million tons respectively, followed by copper and zinc. So the graph also indicates that not only is the transition to the low carbon economy materially intensive, but that intensity tends to increase as the level of decarbonisation increases, or our goals there, in terms of how many degrees we want to keep global warming down to. Next slide, please. So if we want to achieve a below 2 degrees Celsius future, we are going to need a total of 3 billion tons of 17 different minerals and metals, and this includes steel here, to employ renewable energy generation and energy storage technologies over the next 3 decades. That's to 2050. Next slide, please. So where are these minerals and metals going to come from? Well, from a geological perspective, the distribution of so-called clean energy or energy transition minerals and metals is much more concentrated than that of oil or natural gas. So for lithium, cobalt, and rare earth elements, more than 3/4 of the global output is dominated by only 3 nations. And in some cases, a single country is responsible for more than half of worldwide primary production. So we can see that the DRC, for instance, produces 70% of the world's cobalt. China produces 60% of the world's rare earth minerals. And South Africa produces 3/4 of the world's platinum group metals. Next slide, please. And this level of concentration becomes even higher for processed or beneficiated commodities such as cobalt sulfate or cobalt powder, which is the form of cobalt that is used in batteries, or your refined rare earth metals and alloys. So we can see here quite clearly that China has a very strong presence across the board and applies 60 to 70% of the world's processed cobalt products and nearly 90% for the rare earth metals. And because Chinese companies also have a substantial investment in overseas assets in Australia, Chile, the DRC, and Indonesia. Next slide, please, Vanessa. So these high levels of concentration compounded by complex supply chains are generally considered to pose a supply risk to developed countries in particular, with the European Union, for instance, classifying many of the key energy transition metals whose production is concentrated in Africa and China in particular, that's your rare earths at the top, as being very high to moderate risks. So mineral-rich countries, on the other hand, tend to consider the growing demand and high levels of geological concentration as an opportunity to boost economic growth. However, many analysts have been urging the governments of such countries to exercise caution in order to avoid creating expectations that in many cases may not be met, or investing in production that may outstrip demand and lead to minimal benefits. And this is because demand trajectories tend to be on the bullish side and are subject to significant uncertainties as clean energy technologies continuously and rapidly emerge, evolve, and improve. Next slide, please. This is particularly the case for the high-risk or niche minerals such as cobalt, which, with concerns about the mineral supply chain spearheading efforts to reduce the amount of cobalt needed in batteries while still maintaining efficiency levels. So as can be seen in this graph, different technologies, or in this case, it's really sub-technologies, can have significant implications for the demand of not just one mineral, but a whole grouping of minerals, inevitably involving the need for trade-offs. Next slide, please. And furthermore, metal recycling, reuse, and refurbishment will reduce the demand for primary, if not total, supply of energy minerals. So whilst this graph shows that recycling capabilities for lithium and the rare earths remain negligible at this time, recycling rates for base metals currently vary from around 30% for cobalt to 60% for nickel, and are even higher for your precious metals such as your platinum group metals. Next slide, please. And we can see that at current recycling rates, the secondary production can reduce the cumulative demand for clean energy technologies of primary aluminium, copper, and cobalt by between 30 and 40%. So that's the sort of darker shades, with future increases in the end of life recycling rate potentially reducing primary demand even further. Next slide, please. So to summarize, I think there's really little doubt that a transition to clean energy is certainly going to increase the demand for base and niche minerals such as cobalt, lithium, and rare earths. However, the supply of these minerals is geographically highly concentrated, and demand trajectories are subject to large technology and policy uncertainties. So these factors combine to create both demand opportunities and demand risks for mineral-rich countries, mainly developing countries. And this makes an understanding of shifting demand patterns crucial to long-term national planning. So I hope that's the end of our presentation. I hope that's provided a little bit of a base for further discussion. Thank you.
Yeah, thank you, Jennifer. It's interesting to see that there are specific countries where all those minerals are concentrated in. So that's quite an interesting fact that I never knew. Okay, so I'm going to move on to looking at the impacts from closing the mines and opening new mines. So to decarbonize, you're going to have all of those impacts happening, and Mark is going to share that with us from his experiences and from what he's been working on.
Thank you, Vanessa. I really appreciate that, and it certainly is an honor to be joining everyone today. I've been tasked to just generally provide some initial context for us to discuss further about closing mines and opening new mines. And I thought I'd go to a group that I work with, the Landform Design Institute. It was the vision of our visionary on this group is Gord McKenna, and I sit on the board of the Landform Design Institute, and the Landform Design Institute has 12 principles of landform design, but built amongst all of that is this facet of collaboration. Now we've looked at in here is just a sort of a sketch of a whole bunch of different people that are required to start and close mines. You know, from the geotechnical engineer to the traditional knowledge holder, and so on and so forth. So the idea there is that there's a strong facet and a need for collaboration. The Landform Design Institute builds off of that. So now, as we go through to starting to close mines, and we're thinking about, you know, are we having true life of asset stewardship, whether they're closed mines or they're new mines, we end up having a lot of, I would call them symptoms. We think they're actually the issue, but they're actually symptoms. I mean, how often have we use that word? Like, how do I convince that person to consider tomorrow's risks today? Gee whiz, we just can't, you know, we don't have a materials balance, don't have a water balance. You know, my perspective is I've never met a closure plan that's ready to execute, right? And so we get closure plans with uncertain outcomes. They're never ready. They're very rarely execute, or they rely on technology that may be not approved or within legislation. Here's another symptom: minimum amount of progressive closure works is done. We deprioritize those closure opportunities. I mean, you can imagine. I live in the city of Calgary. You know, well, you know, it's really hard to get things done around here. You know, building roads, you can't get from here to there, and everything is a barrier. Everything is hard to do. Imagine if we found some gold under Calgary. You can better believe that they would figure out how to get that gold out, right? So when we think about closure are seen as barriers and liabilities, and developing new mines and new opportunities are seen as an incredible opportunity. So we discount our closure, and we end up with a lot of unrecognized and underfunded liability. And that value of closure is missing from that operational mindset. So my perspective of this is you know, when I take what's required for an NI 43 statement, say, for example, for an asset, I'm really simplifying it down here. And in essence, it results from, when you look at your life of asset, you've got a life of mine plan, a closure plan, and a basis of estimate. And that basis of estimate is made up on the right-hand side of the LOM, the life of mine plan cost model, and the closure plan cost model. And we end up having this LOM, which is the mine schedule of reserves, and the closure plan exists or consists of a schedule, a returning land use, and residual risk. So if we go back to the root cause of those kinds of symptoms that we see every day, which we will see with any new mines, right, is that this sort of piece of the puzzle, this closure plan piece, continues to be left behind. And so we're out of sync and we're not aligned, despite us thinking that we actually are in line. And the real piece that's missing is returning land use. Right? That's literally the piece missing, right? I live in fortunate to live in a gorgeous area of Calgary and Alberta. This used to be farmland, agricultural farmland. But a landowner, the city of Calgary, a developer, some financing people, investors, home builders, they all got together, saw a vision of changing this to residential. They all agreed on what that residual risk would be because there was governance around that. And then they went up and went about doing it, and it was done. And there were no barriers, right? From a perspective in the mining industry, we mine really well, but we would have to really self-reflect to think, are we actually thinking of closure as core business? And I think the symptoms on the previous page we see all the time is all a function of that. Perhaps we're actually not having enough self-reflection as to whether closure of a mine site is actually core business, because this is the piece that we're missing, this returning land use. And the beauty of that, as we transition into new technologies, green energy, decarbonization, is we have this opportunity to actually set that future land use for our mining landscapes and landforms, the ones that exist now and the future ones, with that future vision in mind, because it's right here. The future is now and here today. So go back to the 12 principles of landform design, and I'm just going to highlight 2 of them, which is number 1, mine with the end in mind. Create a shared vision for that reclaimed land among the mine, the indigenous people, the local communities, and you work together to earn that trust. And then the 11th landform design principles is acknowledge that land is going to revert back to the local community. Support that duty of stewardship. Reclaim every square meter, or reclaim that to a future land use that would have some economic benefit for the area. I think Gaylor could touch on a really good point. There are a lot of incredibly skilled workers in the coal mining industry. To lose that skill and not allow them to transition to the next industry would be quite a shame. So in respect of what we're doing is that we believe that this nation to nation connection, and this one we're talking about a group in Saskatchewan, Desnethe Group, to be able to actually execute this closure work and have new projects where the people who are actually part and own the land and with the land, that you're collaboratively doing this work with them, so that at some point in time in the very near future, the need for an impact benefit agreement just simply doesn't exist, because you built that trust and you're actually working collaboratively with the people in the community around you in order to be able to move forward. Thanks, Vanessa.
Thanks, Mark. That's really interesting. And just, the social aspects are such an important thing. And, when I started my career, often people didn't even consider the social aspects. And it was all about the environment. And now it's more transitioning, and there's a huge focus on the environmental consequences and social injustice. And just thinking of closing those mines, you're going to have major social impacts that could arise. And Jessica Edwards from SRK is going to elaborate on that for us, because Jessica's been working quite a lot in that space. So Jessica, I've got your slides and I'm going to share my screen.
Thank you for inviting me to this decarbonisation panel discussion. I must add to what the previous panelists said. Mike specifically said that closure is often the last thought. With my experience with mines and closure, is that the social transitioning aspects are often only considered at the very end, when it's almost too late. So there's a huge emphasis on trying to get people to consider the social transitioning aspects of closure way ahead of time. We've also seen that decarbonisation will result in a major job losses in the coal sector. Gaylor emphasized a lot of those statistics, and we will see going forward that there will be various knock-on effects of these job losses. And then lastly, the closure of power stations is likely to involve similar issues to the closure of coal mines, for example. And I think, a lot of what we've seen happening in the industry is likely to be repeated. But what we'd like to see is also that there should be a reskilling of employees. Economic resilience of communities should be incorporated into plans for the closure of these mines, and then considering diversification of local economies. So some of the social impacts that I've picked up during my work in mine closure, some of these might be obvious and some not so much, is the reduced access to services and facilities. Mines previously have had a paternalistic outlook on communities. They've been providing services and facilities, And there's a big emphasis on mines trying to step away from these long-term responsibilities in terms of facilitating these services and managing it and servicing it. So there's also an expected decrease in the personal health and well-being of employees. This is directly linked to the lack of or reduced services that's provided by mining communities and mining houses. And we can lump Eskom together with these. And then also we can expect the job losses to result in reduced income, which will then also result in a reduced health care accessibility. Then, of course, the loss of employment and reduced support to employees. Often we don't account for all of the other services and support services that mining companies and Eskom will provide to their employees. These are often not recorded technically in your salary, and those type of things will also have to be considered as part of the retrenchment packages. Often in such scenarios where there are job losses, we feel that we find that there's a lot of conflict, tension amongst employees, their families. Often when there's tension in the household, those tensions will escalate because of the the fact that there's going to be job losses and people are going to be retrenched. And then obviously there will be a conflict within the community as well, because some of the companies will also be made redundant. Then we have a loss of skilled professionals. We see this sometimes in communities where the focus is mainly on mining. And we've seen that employees often would like to retain their skills in the mining industry or in the industry that they have experience in. So it's not an easy transition from, for example, mining to agriculture. And that means that a lot of these skilled people might be looking for opportunities in other provinces or even outside South Africa, which means that there will be a bit of a brain drain if we do not put measures in place to reskill these people into cleaner options. Then we can also associate mine closure with the deterioration of social services and infrastructure. I think this is very much linked to the first point that I made, but specifically in terms of the fact that corporate social investment projects and those type of projects that's normally linked with the social and labor plan of a mine, those will now cease to take place, and it will just mean that there's a reduced social investment in the community. Linked to also to conflict is your social fear and anxiety, which will increase, directly linked to obviously retrenchments. And then there will be a knock-on effect on the vulnerable persons in the community. So those that are reliant on people of, that are employed. So that will normally be the children, the youth, the elderly and disabled. So just a couple of things that we can consider going forward is that we really need to have active and genuine dialogue with communities. When closure is considered, people are often hesitant to talk about it because retrenchment can rattle people a bit. So often this discussion only happens right at the end, and it takes people by surprise. And I think there needs to be a lot more discussion in terms of what's going to happen, even as 10 years from now. Just trying to get people's input ahead of time before it is too late to consider and implement some of their suggestions. Based on my experience, people actually have really good input, and they can contribute significantly to our design of post-land use and alternative income generating projects if we actually incorporate their input ahead of time. Then we've also seen that the Department of Mineral Resources and Energy developed a strategy on mine closure. There they're focusing a lot on economic diversification of mining regions. And I think in this case, the Malahleni area, where it's mainly going to be affected because of the coal closures, that would be a good strategy. Then developing re-employment opportunities in clean industries will be key. Like I said, mostly people would like to, partake in the industry that they were part of and where they've gained their skills and experience. So where there's opportunity for easy transfer to perhaps a different mining environment, that would be advisable. Then we also need to look at investing in people's future through training and business development. And this needs to happen not during closure or not even 5 years before closure, but it can really be happening throughout the life of mine or the operation. And that needs to be considered as part of your process in planning and preparation for closure. Then meeting your existing socioeconomic obligations. We've seen it many times where social investment projects are very much dependent on the company being there to maintain infrastructure. So plans need to be made for that infrastructure to be transferred to municipalities or local governments, and that capacity development must take place while the mine is in place. If there has been any resettlement as part of the mining process, that needs to be resolved, and all of those issues will have to be closed out before mine closure can be considered. Then it's very important to promote self-sustainable local economies through the capacitating of suppliers. It's key that suppliers must be able to branch out their services so that they not only supply mine A, but that they could, for example, supply different industries like agriculture or tourism, that there's different opportunities for them, that all of their eggs is not basically in one basket, or that not all hinges on one contract. When you are considering closure options for mines or industries, developing partnerships will be very important. Like I said, collaborating with local municipalities and other partners, it doesn't have to be government, will be important going forward. And in a lot of cases, there will be a requirement for capacity development within the local municipalities. Not all of them will have the resources or the human capital to address some of these gaps, and that capacity building needs to take place while the mining operation is still there and able to, influence the situation. Then obviously fair retrenchment will need to be focused on, and there needs to be potential investment of those retrenchment packages into some transitioning projects. So oftentimes we look at alternative land use options, and these could, for example, be solar farms, wind farms, where employees can actually invest some of their retrenchment packages back into a development project, and they can actually, from the dividends, live off that money if they need to, or have a nice pot for rainy days, I suppose. And then lastly, like I said, government capacity to man infrastructure and services supplies, that will need to be considered and planned for. And then monitoring will also be key component to making sure that whatever you've been implementing actually reaps the results that you want, and that there should be intervention if any of your actions have failed.
So Taryn, I don't know if you are there, if you could carry on.
Okay, good morning, everybody. I'd just like to take this back now to a South African perspective. And the first thing I'd like you to see is, if you look at a map of South Africa and you see all the red on this map, this is all the renewable energy projects in South Africa currently and that are about to be developed. This is from the Department of Environmental Affairs database of all the projects that they have today that have applied for EIAs. If we look at the Western Cape, you can see there's quite substantial conglomerates of these renewable energy projects that have been authorized. And I would like to look at the Cookhouse area. If you look at the scale of 50 kilometer radius, you can see these wind energy facilities, and much of these have been developed already, consist of very large land portions. And just imagine how many wind turbines are over this area. And then in the Uppington region, I just want to show you that these are the solar projects. This is just a zoom in of one set of solar clusters, and you can see the expansive land that we're taking to cover with these solar panels. So before we start talking about the renewable energy aspects, I just want to go back on the previous presentations where you noted how many minerals are being mined and how many minerals we need to mine to create a wind turbine, to create solar panels, to create battery storage. And we've got to take it back to thinking, well, where these minerals come from. They're not all in South Africa. So these minerals need to be mined globally. And then from a global perspective, they then need to be transported to the manufacturer. Then it takes, well, before manufacturing, it needs to be refined into the actual metal, then manufactured or melted and smelted into the right shapes and sizes. And then from there, we've got to then import the goods, or the exporter will export it to us. And all of that consists of a massive carbon footprint. And so we're looking at quite a lot of background is working before we're saying we're installing renewable energy. So if we have a look at the slide over here, we're looking at the wind energy turbine, and the statistics have been given before. And I'd just like to highlight the fact that 85% of a wind energy turbine can actually be recycled. But do we have the facilities in Southern Africa or South Africa to do this? You know, many of these components, we may not have the ability to recycle all these different metals that come out of these different things. And specifically, if we look at the blades are not made of all these nice renewable, these nice recycling elements, but they're actually made of materials that can't be recycled. I know in America, there is somebody that is trying to melt the plastic out of these blades and the fiberglass, and then using it to mold into other things. But the rest of the world is not on that page yet. And your blades have a 10-year life cycle. So it really is a problem that we've got these turbines that we're putting up and saying they're green energy, but what are we doing with these things at the end of life? So then looking at solar energy, we've got quite a lot of elements, as described before, that go into our solar panels. And as previously I said, that we've got to import and export and manufacture and mold and everything before they get here. And then at the end of the day, we need to dispose of them and recycle them. But unfortunately, we don't have very effective recycling facilities in Africa to do this. And then we look at battery storage and the chemicals and plastics and metals that are in there. You get two types of battery storages that are being used, the flow battery and the lithium ion battery. And it's very well, in bringing these batteries in, some of them are actually installed on site and all the components are brought to site. And some of them are actually brought in as a fixture. But what happens? Yes, there is a large percentage of these that can be recycled, but it costs money to recycle. And do we have the facilities to do such a thing? So we're looking at all these renewable energy options, and we're looking at the greenhouse gas or the carbon neutrality footprint that we're contributing to. But in the calculations, people are negating to forget the impact from the mining, the transporting, and the manufacturing of these facilities, and then the disposal of them at the end of life. I pulled some of these pictures out, and also some places have really written some really good information and put it in the news. And one picture I'd like you to have a look at it is the blades from the wind turbines, how they're dominating landfill sites. So what is going to happen in the future? Irina estimated actually that global PV waste streams would grow from 250,000 tons at the end of 2016 to more than 5 million metric tons by 2050. Are we ready? Is South Africa ready for this? Tanzania's solar energy production has so much, they've mentioned about all the low income houses needing lights and electricity. So we're installing these solar home systems in masses. USAID just supplied 550,000 solar home systems to Malawi, but there's no facilities to recycle these things or reuse these things. And they're not even ending up in e-waste facilities because we don't have any. We've only got 3 in Africa, one of them in South Africa. So we have challenges in Africa in terms of renewable energy. If we look at the electric cars and how many tons of batteries we are using and the rate of change in the world of how many batteries we are going to use, it's dramatic. 7.8 million tons per year by 2040 of waste batteries we're going to have. Where are we going to put them? You know, Eskom is driving towards clean energy and using battery storage, and their plan is for 2,088 megawatts of capacity. That's what their aim is. But we're sitting with not a very good way to recycle or to reuse all these different elements. So to conclude, us as EAPs, environmental practitioners, we need to consider this when we write our EIAs, when we write our EMPs. We need to consider, where are we going to dispose of these things? It's not good enough for us to say that it's got to be sent to a recycling facility or the elements have to be recycled at end of life. We need to guide our clients in a better way. And at this point in time, in South Africa, we have very, very few solutions. Yes, some of the metals can be recycled and some of the battery components can be recycled. As a whole, globally and in South Africa, we have many challenges. These are not the only impacts to the environment that we're having from renewable energy. We can look at creating ecological vacuums, creating shaded areas by solar panels, where we're saying in our EIAs that vegetation can grow under solar panels. What vegetation grows under solar panels in the middle of the Karoo? Alien invasive species. So there's many impacts that we need to look at and we need to focus at. And once we identify all of these impacts, and then we calculate the true greenhouse gas emissions from our renewable energy, and also look at these impacts in their entirety, and decide how are we going to mitigate effectively and accurately, then we can talk about real green energy. Thank you.
Thanks, Taryn. That is quite a lot of food for thought and stuff that a lot of people will definitely not be thinking about, which you've definitely raised awareness on. So maybe, Mike, if you would like to just carry on with the future visioning for mining. And I know you've covered this so well in some of the talks that you've been given. And yeah, just so that it's not all doom and gloom, you know, and we know that there is a way and there is a future that we can look forward to.
So I wanted to communicate what I thought could be 4 visions for the future, and it does build off a little bit of what I had spoken about earlier in our panel session here, where it's community engagement as a business strategy, fully integrated mine closure planning, tailings redefined as an asset, and mining as a temporary land use. So, you know, in general, I think that you can't get on to LinkedIn or somewhere else without falling over the words E, S, and G. That environment, social governance aspect is out there, and for very good reason. As an industry, we need to build and rebuild our trust with impacted communities, and building trust comes from self-awareness and being vulnerable about where we've been, learn from that, not beat ourselves up about it, and learn and move forward. So building that trust with impacted communities starts with your community engagement. It goes beyond just consultation. It's actually about collaboration, as I talked about before. So, for example, if you went back 20, 25 years, you know, if you asked a board member of a mine operation company, they'd say, you know, what's their primary duty to it? Be to shareholders. You know, and even now, it's even evolving now, where you have you know, you'd ask, well, the typical makeup of a board is, oh, that's the finance person, that's the geologist person, that's the. My perspective is that every single person on a board, rather than having your ESG specialist on a board, must be ESG competent. And so mining companies need to be clear that they're partners with the surrounding communities. I mean, I sit on the board of my company, and my duty is not just to our shareholders. My duty is to the communities that I work with. My duties are to the people and the business that we serve and serve us. So, you know, delivering training, job opportunities, a sustainable economy. So community engagement also provides an opportunity to develop a more diverse and equitable and inclusive workforce. So we need to work with our impacted communities to develop long-term economic benefits. And I gave the example of something that we're doing, of collaborating jointly with Indigenous-owned businesses and with First Nations businesses here in Canada, because these are many times the places and the people who are actually impacted. So it's not just about listening to the communities, it's about actually clearly demonstrating what we're acting on. So, you know, one of the ways to think about it is that, you know, often we come to a meeting, we come to a place to be able to make a point, right? And you want to be able to make a point. And it's actually sometimes fun to be able to make a point, to be that louder person in the room, to make a point, right? But rather than that, we need to come to these things about being able to make change and to actually make a difference. And that's the difference in terms of being able to have engagement and collaboration with the communities as a business strategy, from my perspective. So there's always been a disconnect between the people who develop a mine plan and a schedule and those people that develop the closure and environmental monitoring plan. And as I talked about before, the future vision asks the key question: why does that difference exist, right? And so rather than that we should be thinking of a whole bunch of different plans, we would argue, or I would argue, that we need to have one plan, a fully integrated plan, where closure is as much part of the mine plan as extraction or processing. And until we're doing that, until we're fully integrating that, until closure is literally core business of mining, we won't be able to actually continue to move forward in a sustainable manner. So integrated planning, and also opportunities for lowering greenhouse gas emissions by limiting material rehandling, provisions for battery powered semi-autonomous fleets, etc. So just imagine you're building a mine waste landform, a mine rock stockpile, or a tailing storage facility. Imagine the difference that would be made if you're actually planning to progressively reclaim that and put a solar panel farm on there, and then actually be your own off-taker of green energy, right? Rather than waiting for that area to be done sooner and completely driven by extraction and processing. So tailings as an asset. There's probably well over 3,000, 3,500, 4,000 active tailings dams around the world, and you know, countless more inactive ones. They're widely regarded as one of the most challenging to manage and the highest risk mining landforms. But what if that tailings dam was not a liability resource? we just saw our presentation just previously about the vast tracts of land that are required for wind farms, required for solar panels, right? What's one of the major issues associated with tailings dams is the vast tract of land that it actually covers, right? So why aren't we thinking as tailings dams, mine rock stockpiles is our next best place to put these solar panel farms, as an example? Now, the other aspect too is that what if that tailings dam wasn't a liability or resource? We also talked about all those rare earths, those metals, that nickel, that cobalt, right? As mineral processing improves, so does metal recovery rates. In general, past processing may have been less efficient, leaving high residual grades of metals in legacy tailings storage facilities. And from my experience, in many cases, they're also a source of critical minerals or rare earths because we actually weren't looking for them before, right? So this future vision dewaters and processes the materials currently stored in legacy tailings dams. And again, wouldn't it be amazing if the energy we're doing to dewatering is energy we created ourselves on our own mined landforms? And that's being green energy. We leave the remaining material behind in, say, dry stack landforms, a lower environmental risk, and with a substantial economic upside. And we keep the jobs and the skills that are there already there, and just transition to this new perspective. So mining as a temporary land use. I mean, there's a significant number of closed mines and sites and care and maintenance around the world. You know, my future vision for mining would be that mine sites are all considered as being temporary uses of the land, and that every mining operation is actively working towards a high value returning land use. You know, I talked about before, my opinion, the barrier to achieving closure and transition is that future land use, and defining it and actually completely driving ourselves towards this. From an investor perspective, you're actually bringing on and widening out an entirely new pool of investor if you're talking about developing a mine that may end up being a pit lake that has floating solar panels on it, as an example. So I think that from what we see today is, as well as what we've what I've spoken to today, is that like this future is not, it's not actually tomorrow. Like this future is actually today, right? I love the discussion around the need for the global climate change. Like that literally is today, right? And so this different perspective, this change, it absolutely comes culturally, like we talked about, that culture is actually changing and conversations is changing, but it also must come through governance, right? A much harder and deeper look at the importance of future land use as we develop our mines and start to close our mines, and governance always precedes culture, and then you continue to build that culture. So thanks very much, Vanessa.
Thanks, Mark. It's really good to see that. And I think we do have to look forward to the future, not just focus on the challenges, but look at the solutions and know that, you know, there are those challenges, but they will take time to sort out. And there will be impacts that we've got to mitigate and new land uses that we've got to define for mining.
Yeah, and I think Vanessa, is that just to pick up on what you said, is that once we start, like things start to snowball, and all of so we start to create this whole new ecology, right?
And it's a different way of thinking, you know, and things are changing, and you've got a whole lot of passionate people doing this type of work. So yeah. I think there will be solutions that will come forward, and it's happening all over the world. You know, people are looking for those solutions to the challenges.
Thank you, Vanessa.
Mark, I've got one question for you. In South Africa, the problem we have is that in terms of mine closure, there's a large proportion of the mines in South Africa that have have not closed, or the mines have gone bankrupt, so they've left them derelict. And our Department of Minerals, Resources and Energy have got a schedule of when they are going to look at the decommissioning of these mines. So when renewable energy companies come and they see land that's previously been mined and haven't been rehabilitated, they have wanted to take the same approach and develop on old damaged areas from mining. However, there seems to be quite a block in the system, because when you take it to the officials, they say that you can't develop here until you get mine closure. But the renewable energy developer does not have mining rights. It has the land use right, and the mining rights are sitting with BMR.
Yeah.
So we having that as a major challenge in this country, because we have considered this approach.
So and you know, in the interest of closing out here and being able to get onto other meetings, I'll be fairly brief, Taryn. Is that the one solace that I can give you is that you're not alone, right? It's happening in your country. It's happening all over the world. This challenge that you have is happening all over the world, right? And this is why I mentioned about the governance and culture, right? So culture wants to be able to do it. The governance, the legislation doesn't exist, right? And so governance always has to be able to be put into place to actually have that legislation of mix. And there's different jurisdictions in the world. Kentucky in the Appalachia region in the United States is an example of that, where there is legislation that's put in place to address exactly what you've talked about, right? And so governance first, then culture, and perhaps culture drives governance. But the point being is that you require a change in legislation, and that requires a change in having a discussion at perhaps even the highest levels within your South African government. And again, this is exactly how it is in almost every other jurisdiction in the world.
That's great. Thank you very much. Well, let's hope that our legislation changes too. And we've always been at the forefront of environmental legislation, and this would be such a great avenue for us to explore.
So maybe we can end off there.